Hello everyone. Today we are going to discuss about the next topic related with the spiral gear, that is efficiency of spiral gear. Now this efficiency of spiral gear is very important topic when we studied the spiral gear. The numerical based on it will be asked in your objective type of examination. So let's just start with efficiency of spiral gear. So here we have a constructed figure. Here we have the driver gear 1 and driven gear 2, which is in mesh. Now this is the axis of gear 2 and this is the axis of gear 1. Okay, so here we get the alpha 1, that is spiral angle of gear 1, and alpha 2 is the spiral angle of gear 2, that angle made by the teeth of the gear with the axis of gear, and theta is the summation of alpha 1 plus alpha 2, and theta is nothing but the shaft angle. We already know about this. Okay, then see, this red line is represent Rn, where Rn is the normal reaction at a point of contact. So when two gears are in mesh, the normal reaction by driver to the driven, and equal and opposite reaction by driven to the driver. So that is represented by Rn. Now here we have the R, which is represented by blue line. And what is that R? This R is the resultant reaction, because as you can see in between this R and Rn there is angle phi. So here is the phi is not pressure angle, the phi is nothing but the angle of friction. So by considering friction we get this resultant R. Okay, so this R is the resultant force, Rn is the normal force, and this phi is the friction angle. Now with the tangent of the tooth we have F1, that is the tangential force, and F2 on gear 2, that is tangential force of gear 2, and this FA1 is the axial force or thrust load on gear 1, and FA2 is the axial force on gear 2. Here we get alpha 1, angle between tangent and normal, that is here it is represented by alpha 1, and again here we have the alpha 2 with normal plane and transverse plane, we get the spiral angle alpha 2. Now here we are going to calculate efficiency. So nu is equal to output power divided by input power. We know that tangential in gear, tangential force help to transmit the motion and torque. So at tangential force we get the input and output power. So by using a formula, power is equal to force into velocity, so we just put tangential force into velocity v1, similarly tangential force into velocity v2. Now let's just derive the equation for F1. So F1 in terms of R in triangle OQP. So in triangle OQP, the angle POQ is alpha 1 minus of phi. So angle POQ is equal to alpha 1 minus of phi, and this F is the adjacent and R is the hypotenuse. So what we get F1 is equal to R cos of alpha 1 minus of phi. Okay, similarly in triangle OST, see, in the triangle OST, this angle SOT is alpha 2 plus phi. So angle SOT is equal to alpha 2 plus phi. So F2 is equal to, F2 is adjacent edge and this R is hypotenuse. So F2 is equal to R sine of alpha 2 plus phi. Okay, so let's write efficiency is equal to F1 is R cos of alpha 1 minus phi, and F2 is, sorry, it is F2 by F1 because output power divided by input power, so it is F2 by F1. So it is R cos of alpha 2 plus phi divided by R cos of alpha 1 minus of phi into V in terms of pi d n, so it is pi d2 n2 divided by pi d1 n1 divided by 60, get cancel. Again RR get cancel, pi get cancel, so what remains is d2 n2 divided by d1 n1 into cos of alpha 2 plus phi divided by cos of alpha 1 minus phi. Efficiency, let us say this is equation 1. Okay, now let's convert this d2 and n2 in terms of t firstly, and then let us convert this term in terms of angle alpha and theta. So firstly we know that d2 is equal to pc, that is circular pitch, into number of teeth divided by pi, because d2 is m into t, so it is p circular pitch divided by pi into t, or we can say that this circular pitch is transverse circular pitch, so pt2 into t2 divided by pi. So let us just convert this transverse circular pitch into normal circular pitch, so it is pn divided by cos of alpha 2 into t2 by pi remains as it is. Similarly d1 is equal to p t1 t1 divided by pi, so let's convert this pt1 in terms of pn, that is normal circular pitch, so it is pn divided by cos of alpha 1 into t1 upon pi. So when we get d2 by d1, it is equal to, so it is pn divided by cos of alpha 2 into t2 divided by pi whole divided by pn divided by cos of alpha 1 into t1 divided by pi. So this pi get cancelled, pn get cancelled, so what remains, t2 upon t1 into this cos of alpha 1 is goes on numerator, so it is cos of alpha 1 divided by cos of alpha 2. So we get d2 by d1 is equal to t1 upon t1 t2 upon t1 into cos of alpha 1 divided by cos of alpha 2. Let us say this is equation A. This formula is important to solve the numerical, so let's just remember this formula. Then n2 upon n1 is equal to, we know that n2 upon n1 is equal to t1 upon t2. This is equation B. So multiply equation A by B. So what we get, d2 d1 into n2 n1 is equal to, so d2 is t2 upon t1 into cos of alpha 1 divided by cos of alpha 2 into t1 upon t2. Again t2 and t1 get cancelled, so what we get, t2 n2 divided by d1 n1 is equal to cos of alpha 1 divided by cos of alpha 2. Put this value in equation 1. We have this equation 1 for efficiency, and here we have d2 n2 d1 n2, so let's put this value over here. So we get cos of alpha 1 divided by cos of alpha 2 into cos of alpha 2 plus phi divided by cos of alpha 1 minus phi. Now here we are going to use a mathematical formula. Cos A into cos B is equal to cos A plus B plus cos A minus B. Okay, we know this mathematical formula, so let's apply this on above equation. So we get cos of cos A plus B, so cos of alpha 1 plus alpha 2 plus phi plus cos of A minus B, alpha 1 minus of alpha 2 minus of phi, divided by cos of A plus B, so it is alpha 1 plus alpha 2 minus phi plus A minus B, cos of alpha 2 minus of alpha 1, this become plus phi. Okay, so see this equation carefully. Cos of alpha 1 plus alpha 2, when we use the same handed spiral gear, then that alpha 1 plus alpha 2 is nothing but shaft angle. So instead of alpha 1 plus alpha 2, let's put the shaft angle. So it is cos of theta plus phi. Similarly, here cos of alpha 1 plus alpha 2, so it is theta minus of phi plus remaining term as it is, cos of alpha 1 minus of alpha 2 minus phi divided by cos of alpha 2 minus of alpha 1 plus phi. This is equation for efficiency of spiral gear. Now let's just modify this equation for maximum efficiency of spiral gear. Since this theta and phi are constant, the efficiency will be maximum when this value become a maximum value, and when we equate this cos of inside bracket term equal to 0, then and then only we get one value. So let us say cos of alpha 1 minus of alpha 2 minus phi is equal to 0 for maximum efficiency. So alpha 1 is equal to 1. The maximum value is 1. So alpha 1 minus of alpha 2 minus of phi is equal to 0. So alpha 1 is equal to alpha 2 plus phi, and alpha 2 is equal to alpha 1 minus phi. Let us say this is equation C and this is equation D. Now in equation C and D, let's put theta is equal to alpha 1 plus alpha 2, that is alpha 1 is equal to theta minus of alpha 2 and alpha 2 is equal to theta minus of alpha 1. So what is our equation C is alpha 1 is equal to alpha 2 plus phi. So in this equation let's put instead of alpha 2 this value. So alpha 1 is equal to theta minus of alpha 1 plus phi. Let's just shift this alpha 1 on another side, so it is 2 alpha 1 is equal to theta plus phi. So alpha 1 is equal to theta plus phi by 2. Okay, similarly this is our equation C. Similarly in equation D, that is alpha 2 is equal to alpha 1 minus of phi, this is our equation D. In this equation let us put the value of alpha 1 in terms of alpha 2 and theta, so it is theta minus of alpha 2 minus of phi. So again let's shift this alpha 2 on another side, it become 2 alpha 2 theta minus of phi. So alpha 2 is equal to theta minus phi divided by 2. This is the another equation. These two are the condition for maximum efficiency. Means when we calculate spiral angle in this way, we get maximum efficiency condition. Okay, so let's just So let's just put this condition for maximum efficiency in equation. Let us say this is equation capital A. Okay, in equation A. So efficiency is equal to cos of theta plus phi. So see, when we put alpha 1 is alpha 2 plus phi, here is instead of alpha 1 it is alpha 2 plus phi. So alpha 2 plus phi, it will be cancelled with this alpha 2 and phi. So what we get, cos of 0, and cos of 0 is equal to 1. Similarly, in below equation, when we put alpha, instead of alpha 2 alpha 1 minus phi, so it is alpha 1 minus phi, again alpha 1 and phi get cancelled, so cos of 0 is nothing but 1. So this is the equation for maximum efficiency. So we get this efficiency equation. Now using of this diagram, let's just derive the equation for F1R and Fa in terms of alpha. So as you can see, here we have the Rn and here is the angle alpha. This Rn is hypotenuse and F is the adjacent edge. So what we get, F1 is equal to Rn into cos of alpha. So it is alpha 1, or we can say that Rn is equal to F1 divided by cos of alpha. Similarly, Rn is equal to F2 divided by cos of alpha 2. Same, we can derive the equation for Rn in terms of Fa2. So Rn is equal to Fa2 divided by cos of alpha. Now axial force. Axial force in terms of F is Fa1 and F, it is the front edge, it is the adjacent edge. So what we get, Fa1 is equal to F1 tan of alpha 1 and Fa2 is equal to F2 tan of alpha 2. Or in terms of Rn, Fa1 is the front edge, similarly Fa2 is the front edge. So in terms of Rn, Fa1 is equal to Rn sine of alpha 1 and Fa2 is equal to Rn sine of alpha 2. In this way, if we get the tangential force, we can able to calculate Rn and Fa1, that is the axial thrust. I hope you get the concept. Thank you for watching video.